Okay, with all the faffing about and trying to get the front panel working, I think we're ready to test it. So I'll just switch it on. Standby light should come on with any luck. Anytime now, no standby light. There we go, standby light is on. Switch the unit on. So far so good. How about the fault? Let's move these wires and cables up the top here. Wow, there's no crackling and carrying on. So the tone board that sits directly behind the bass and treble controls here, and with the display board, there were probably 8 single wire links going between the two boards, between the tone board and the display board. The tone board side of those links were completely cracked. The solder joints were dry and just all of them were broken. So what I've done, you did see me solder in and resolder the links on the tone board side, but off camera I decided to delete all the single wire links and put in stranded, multi-stranded cable, and then extend the length so there was a bit more flexibility, and then resolder those in. So there's no more rigid wire links. I've deleted those. So as it stands at the moment, we should be ready to test. Oh, what a struggle. This has taken 2 days to get to this point. Not solid, but I've had other things to do. But yeah, let's set up our rig again and put this thing through its paces. Okay, so we're all finally connected up. We've got a 1 kHz signal coming out of the SIGGEN at 150 millivolts. That's saturating, well not saturating, but it's maximizing the input on the amplifier. In comparison to the phono input, which comes from your turntable, which is only at 2.5 millivolt input, which is highly sensitive and too right for turntables, which have a naturally lower signal. The SIGGEN's on. It's now feeding into the CD input on the amp. I've got the oscilloscope set to 500 microseconds per division, plus at about 5 volts per division, just to be on the safe side. And we'll see how the waveform looks as I crank up the volume. So it's turned right to 0 at the moment, so we'll slowly crank it up and see what we get. Just keeping in mind that the load is actually across both channels, left and right. Increasing now. Starting to see movement. We're about halfway on the volume. Okay, the trigger's now kicked in. Holding the waveform in the middle. So about 3/4 volume. Now we're full volume. Currently peaking at about 17 volts or 34 volts peak to peak. Well, that's good. So that is currently on the left channel. So I'll disconnect the oscilloscope and we'll go over to the right channel. And look at that, we're seeing the same thing. In fact, I can just barely hear. I think I can. It's imperceptible, but I think I can hear the 1 kHz tone on the power resistors. But this is a good sign. That means, let's give this front face a bit of a manipulation, see if that. There's a bit of jitter on the waveform, but nothing too bad. A little bit of jitter as I adjust the tone. This is the treble, I think. Yeah, that's dirty pots, I think. So they'll need a bit of deoxit or something. And the base. Yeah, the same. Not too bad overall. They are cleaning up the more I use them. Well, that's a great sign. That's a great sign. Geez, I'm here all day. Yeah, look, the treble dial's a bit how you doing. But I think we're, if we put a dynamic signal on the amp like music, I think we'll be fine. Okay, this is good. The power resistors are ever so slightly warm. Okay, so we've got a 17 volt peak to peak, 34 volt peak to peak. We'll take the RMS from that. We'll get a voltage reading across the power resistors and we'll work out the wattage. Okay, so I think you can see, hopefully you can see the multimeter. It's at 12.5 volts AC, 999.9 hertz, which is basically our kilohertz, our 1 kilohertz signal. And that's our 12 across our 8 ohm load. Let's do a quick calculation and see where we're at. Okay, we're sitting at idle at the moment. This close up, we have the multimeter across one of the power resistors simulating a speaker on the amp. The oscilloscope is connected across one of those resistors. And at the moment, we're going to try and calculate the output power of this amplifier. So at the moment, I am measuring the left channel. So I'll slowly crank up the amplifier. I'm off camera at the moment. Right, this is going to maximum. I've maxed out. Currently, max voltage is sitting at around 19 volts, 37 or 38 volts peak to peak. What I want to try and calculate now is the RMS value of the 19 volts. 19 times 0.707 equals 13.4 volts. Okay, we're a little bit shy here because this will be giving the multimeter will be giving RMS value, but we'll take the 13.4 volts given by, the RMS value calculated from the max peak voltage on the oscilloscope. We know the ohm, we know the resistance of the power resistor, so we'll times that by 8. 107.4 watts. Okay, well that's pretty impressive. We'll do the same calculation off the multimeter here. So 11.9 volts, which is already RMS, times the 8 ohms of the power resistor gives us 95.2. So we're basically ballpark of what the output of the amp should be. So let's wind the volume down on the amplifier and we'll change the voltage back, the multimeter connection back to the other channel, as well as the oscilloscope. And I can tell you right now that the heatsink under these power resistors is nice and toasty. Okay, let's go again. So we'll wind right up. This is still using a 1 kilohertz sine wave signal. Okay, that's maxed out. It seems that the right channel is a little bit more stronger as far as output is concerned. We've got 13.1 volts RMS and we're looking at about 19 volt max and 37.8, well it's fluctuating a bit, 38 volts, call it 38. And our signal in is bang on 1 kilohertz I should say. Okay, we'll do that calculation, 13.1 times 8 ohms, 104.8. So we're basically getting our specified output for this amp at this age. 1996, guys. $1 off eBay. And it's easily driving 100 watts. Easily. Fantastic. I guess the next test now is dynamic. And what better way to put a dynamic signal in but by using music. Okay, as my lavalier mic won't do this justice, I'm going to record the sound with my phone as well, even though that still might not do it justice, but at least the phone records in stereo. I'm going to hit play on one of the tracks I've got set up at the moment, and we'll go from there. I may switch from my lavalier audio to the phone audio in post-production, and you'll listen to that as I switch over. Sounding good. Sounding good. Fantastic. Well, if you've made it this far in the video, I'd like to thank you for watching. It's been a little bit different in my direction as far as scenes and my lighting, so I hope you liked it. If you have, throw your comment down below. If you haven't, do the same. But my main goal is to get some more subs and drive this channel even higher. I do want to hit that 1,000 subs before the end of the year. I have had to shift my goal, but that's just the way things go. Again, thanks for watching, and I'll see you in the next one.